Okay guys, today we're going to talk about multi-step mole conversions. Those that consist of 3 to 4 steps. So first of all, you have to remember that you've already learned about some mole conversions. That 1 mole is equal to 6.02 times 10 to the 23rd particles. Now those particles can be anything. This is just kind of an ambiguous measure like a dozen. A dozen is always 12. It doesn't matter what the particles you're talking about are, whether they're eggs or reams of paper. Usually in chemistry, however, those particles are going to be atoms or ions or molecules if you're dealing with a molecular compound, or formula units, sometimes abbreviated FUs, if you're dealing with an ionic compound. We also know that 1 mole is equal to the gram formula mass of any element or compound. So what that means is if you have a compound such as carbon dioxide, let's say, you can just go to the periodic table and look at the gram atomic mass of each of these compounds or each of the elements, add them all together, and you'll have your gram formula mass or molar mass. So if you look at the periodic table, you'll find out that each carbon has 12.01 grams per mole. You're going to add that to your oxygens, and you have 2 of them, and each oxygen is 16.00 grams per mole. So your molar mass or gram formula mass of carbon dioxide is going to be 44.01 grams or grams per mole. Finally, we have one more conversion factor when it comes to a mole, and that is that 1 mole of any substance, as long as it is a gas at standard temperature and pressure, is equal to 22.4 liters. So we can go from moles to particles, moles to mass using gram formula mass, and moles to liters. Now don't forget, this liters does not apply to volume of liquids, only of gases, and only at standard temperature and pressure. So let's get started and give a problem a try. Here we have a problem that's asking us a volume of 3.4 times 10 to the 24th molecules of nitrogen trihydride. And it tells us that this is a gas and it's at STP. So first of all, we need to know, what is nitrogen trihydride? Well, nitrogen is N. Hydride comes from hydrogen, and the prefix 3 means we have 3 of those. So ammonia is actually NH3. So let's get started on a conversion here. We're going to start with our given, which is 3.4 times 10 to the 24th. I'm going to save a little room here, put molecules down here, of NH3. I'm going to use dimensional analysis, of course, to solve this. So I'm just going to go ahead and set it all up like so. Now remember that whatever you have on the top in this conversion is going to cancel with the units on the bottom here. And since I want to get rid of the molecules and eventually into my volume or liters, I'm going to go ahead and put molecules on the bottom here. Now you know from the previous page that we have a conversion factor that compares molecules to mole, and that is that 1 mole of any substance, and in this case our substance is NH3, is equal to 6.022 times 10 to the 23rd particles. In this case our particles are molecules. So now I've got that conversion factor all set, and let's take a look at what happens to our units. Since we have molecules of NH3 on the top here and molecules of NH3 on the bottom here, those two are going to cancel out nicely. And if I were to stop right now, I'd be in moles of NH3. Of course, I don't want moles. I want to move, again, a little bit further and try to get into liters. So since I have moles of NH3 on the top in this conversion factor and need to get rid of it, I'm going to put moles of NH3 on the bottom here. And you know again that you have a conversion factor for gases at STP that tells us that there are 22.4 liters of any gas at STP in 1 mole of that gas. So I can put my conversion factor in like so. So let's go back and take a look again and see what happens to our units. We have moles of NH3 on the top here and moles of NH3 on the bottom here, so those are going to, again, cancel very nicely. Now we can see that all of our units have canceled except for liters of NH3. Always double check and make sure you're done before you actually go through and do your calculations. And we were indeed looking for liters. So I can close this out now and get out my calculator and take 3.4 times 10 to the 24th divided by 6.02 times 10 to the 23rd times 22.4. And if you put that into your calculator, you should end up with an answer of 126.5 liters of NH3. Now you know you want to go back and check your significant figures. Since we only multiplied and divided in this particular calculation, we only have to use one rule. And that rule states that for multiplication and division, you have to look at the numbers that you used in the calculation and go with the one that has the fewest number of significant figures. In that case, that's this number here, only has 2 significant figures, so our final answer should be rounded to 2 significant figures. So your final answer should be 130 liters of ammonia gas at STP.